Hello guys, my name is Krishna and welcome to Code with BK. So in this video, we write a C++ program to check if an integer is a Krishnamurthy number or not. So before we begin, it is a request to please subscribe to my channel because out of 100 viewers, only 3 or 5 are subscribed. More than 95% of my audience is not subscribed and a subscription is very important. So please do subscribe to my channel. So let's begin. So we have to write a C++ program to check if an integer is a Krishnamurthy number or not. Okay, so first I am going to explain you what a Krishnamurthy number is. Then we see how we solve this problem and then we write the C++ code finally. And we also try to solve this problem using an alternate approach so that you can see how we can approach the same problem in two different ways. Okay, so first of all, what is a Krishnamurthy number? So if I have an integer n, say 145, okay, I need to check if this integer n is a Krishnamurthy number or not. I pick out each of the digits of this number separately. Okay, then I find the factorial of each number. Okay, n factorial is basically 1 into 2 into 3 till into n minus 1 into n. Okay, so n factorial is basically the multiplication, the product of all integers from 1 to n. Okay, with this logic we have 1 factorial as just 1, 2 factorial is 1 into 2 equal to 2, 3 factorial is 1 into 2 into 3 which is equal to 6, 4 factorial is 1 into 2 into 3 into 4 which is 24. Okay, and so on till n factorial. All right, we also have by definition defined 0 factorial as 1. Okay, after you find the factorials of each separate digit, you need to add the factorials. Okay, so 1 factorial is 1, 4 factorial is 24. Okay, 5 factorial will come out to be 1 into 2 into 3 into 4 into 5. So this thing into 5 which is equal to 24 into 5 equal to 120 plus 120. Okay, when I sum this, 25 plus 120 is going to give you 145 which is equal to the original value of n. So this integer n is a Krishnamurthy number. Alright, and that is what we need to code. We need to find the digits of this integer n, find the factorial of each digit, add all those factorials into a sum, and then compare sum with n. Okay, so let's go back to my code. Okay, I'm going to write a function bool is Krishnamurthy number. Okay, takes an integer n and it returns true if this integer n is a Krishnamurthy number, returns false otherwise. Okay, the first thing we did was to find the digits of an integer. Okay, to find the digits of an integer, I've already posted a separate video that explains in detail how to break an integer into digits. The link for that video you can find in the description of this video. Okay, so to find the digits of this integer, I basically convert this integer into corresponding string. I then iterate the string from left to right, pick up each character which is basically a digit. Okay, it will be of type char which we convert into int. I'll just show you how. So converting this integer to its corresponding string, we say string n. Okay, so we do toString, okay, and we pass n. Okay, so if n is, say the example we do 145, so this variable string n will store the string form of n which is going to be 145. Okay, we then iterate the string from left to right dot length I plus plus. Okay, we pick up each character in each iteration. Okay, all right, so if we have this string equal to 145 in double inverted quotes, our ch will take values 1, 4 and 5 in each of its iteration. Okay, so we have the digits we want, but they are currently of char data type. We need to extract this integer 1, integer 4, integer 5 from their corresponding char types. For that we do int digit equal to ch minus 0. Okay, so you subtract the value 0 from this given character that contains a digit. Okay, behind the scenes what happens is, we all know all character constants in C++ have an ASCII value. So ASCII value of 0 is 48. Okay, 0 equal to 48. So the next value 1 is 49, the next value 2 is 50. Okay, so when we do ch minus 0, we're actually subtracting the corresponding ASCII values. So suppose if ch is this character that contains the digit 1, ch minus 0 is going to be ASCII value of 1 minus ASCII value of 0. So ASCII value of 1 is 49, ASCII value of 0 is 48. So 49 minus 48, you get digit 1, which is you get as an integer. Okay, so for 3, we will have 51 as the corresponding ASCII value. For 4, it is going to be 52. It is 52. It's not going to be, it is 52. So if this single character ch is this character that contains the digit 4, ch minus 0 is going to give you ASCII value of 4 minus ASCII value of 0. 52 minus 48, it is going to give you the integer value 4 that is stored in this variable digit. Okay, it's a very standard way of converting a character that contains a digit into a corresponding integer digit. Okay, so we have the digit, okay, just as we discussed. All right, we need to find the factorial now. So to find the factorial, I'm going to write a function factorial. Okay, takes an integer n and returns the factorial of its integer. Okay, so from what we know about factorials, all we need to do is find the product of all integers from 1 to n in order to find factorial. All right, so I'll say int, say p is 1. Okay, you can say f for factorial or p for product. Iterate from 1 till less than equal to n and I plus plus. Okay, you multiply p into the corresponding value of I. Okay, so when this for loop completes, we have accumulated the product of all integers from 1 to n in this variable p, and then we return variable p. Okay, and this function will work correctly for n equal to 0 as well, because if n is 0, I is 1 and I less than equal to 0 will be false. So for the value n equal to 0, this for loop will not run at all. In that case, p will stay 1, and that's what is returned. So 0 factorial will be returned as 1, which is correct, and that's what we want. So whenever you're coding functions, you make sure that you take care of the border cases. Okay, so we have a factorial function. So what we say is int digit factorial. Okay, the factorial of digit is going to be calling this function and passing this digit, right? Okay, so please don't get confused between this n and this n. Okay, these are separate functions, right? They take separate arguments. This n is local to this function and this n is local to this function. Okay, so in the example we discussed, we need to add all the factorials into a sum. So I take a sum equal to 0 before I start the for loop, and then in each iteration of this for loop, after I calculate the factorial, I add it to my recurring sum, and finally I have to check if this sum equal to my original value. So if this condition is true, it means the sum that I have calculated by adding the factorials of each digit is equal to the original value n. So n is a Krishnamurthy number. Okay, so let me just take the case of n equal to 145 in our main. So see out is n a Krishnamurthy number. Okay, and I use a ternary operator to print yes no. Okay, so I pass n question mark. If the return value is true, I print yes. If the return value is false, I print no, and then I change the line. So this is the function to check if an integer n is a Krishnamurthy number or not. Let's run this. G++ and c dot slash Krishnamurthy number. Yes. All right. Let's take another example. Say 0. Okay. Now 0 is not a Krishnamurthy number because 0 factorial, the only digit in this number 0 is 0. So 0 factorial is 1, which is not equal to the original number 0. So 0 is not a Krishnamurthy number. Let's take another example, say 25. Okay. 25 is not a Krishnamurthy number because 2 factorial is 2, 5 factorial is 120, 122 is not equal to 25. Okay. I will try to print all the Krishnamurthy numbers between 1 to less than equal to say 1000. Okay, so if this ith value is a Krishnamurthy number, I print out Cout I is a Krishnamurthy number, change a line. Okay, I comment this out. Okay, so this is going to print me all Krishnamurthy numbers from 1 to 100 inclusive. Okay, so compile, run. I have 1, I have 2. Compiling and running again. Okay, so 1 and 2 are Krishnamurthy numbers because 2 factorial is 2, which is equal to the original number. Okay, all right, let's just increase the range, make it 10 to the power 4. Compile, run. Okay, still the same. Let's increase the range once again, 10 to the power 5, compile, run. So we have 40585. So let's check this out. So we have 40585. So digits are 40585 factorials of each. Okay, so 4 factorial is 24, 0 factorial is 1 by definition, factorial is just we discuss 120. Okay, let's find out 8 factorial is 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8. Okay, so this value is 120. Okay, into 6 into 7 into 8. So 6 into 7, 42 into 8. 8 to the 16, 1 carry. 8 for the 32, 33. Okay, into 336. Okay, so 336 into 120, old school multiplication, 0 0 0 cross. 2 6 are 12, 1 carry, 2 3 are 6, 7. 2 3 are 6 cross cross. 336. Okay, 0 2 7 6 13, 1 carry, 69 10, 1 carry, 4. Okay, so this is 40320. In this we add this. So 120 plus 120 is 240 plus 1 241. 241 plus 24 is 265. Okay, so 40320 plus 265. So 58504. So 40585, which is equal to the original number. Okay, let's try maybe a longer range, 10 to power 6. Okay, g plus plus. Nah. So we know how to check if an integer n is a Krishnamurthy number or not, and this is the solution. Okay, so an alternate approach to this could be when you use the while loop to find the digits of an integer. Okay, so if I take is Krishnamurthy number 2, make this 1. Okay, and we use 1 for now. Okay, right, we'll still have to have the sum. Okay, and the sum has to be equal to n in order for this to be a Krishnamurthy number. Okay, so the standard way to extract digits from an integer using a while loop is while n is not equal to 0. Okay, what we do is basically extract each units digit in each iteration. So I say int digit is n%10. Okay, any integer %10 will give you the units digit in this integer n. So what I'm trying to say is, if you do n%10, okay, 43% 10 is remainder. When 43 is divided by 10, you get 3. You do 2% 10, remainder when 2 is divided by 10, you get 2. You do 15486% 10. Okay, quotient is going to be 1548 and remainder is going to be 6. So very standard way to extract the units digit from an integer n. Okay, then we find the digit factorial. Okay, in the same factorial method, then we actually remove this digit from n by doing n equal to n by 10 integer division. How? So again, if my integer is 43 integer division by 10 just gives you the quotient, leaves out the remainder. Okay, so this gives you 4. 10 for the 40, which is the quotient, so we lose out 3. Similarly, 2 by 10, okay, quotient is going to be 0 in this case, remainder is 2. Okay, so we lose out 2. Similarly, 15486 by 10 integer division by 10 will give you this as the quotient, 1548, and you lose out 6, the units digit. Okay, so this happens till n does not go to 0, because when n is single digit by 10 will give you 0, and that is the stopping condition. Right, so using this while loop you can extract each unit digit in every iteration, and since we just need to find the sum of factorials of all digits, so extracting the digits from right to left will give us all the digits, and then we find the factorial and add it to the sum the way we did here. Okay, and finally sum equal to n. Okay, all right, let me just run this for Krishnamurthy. All right, compile, run. Okay, we don't get any Krishnamurthy numbers from 1 to 1000, where we were getting 3 Krishnamurthy numbers from 1 to 1000. This is happening because the value of n will go to 0 after the while loop completes, because it's the stopping condition. So n will go to 0, right? So we lose the original value of n. So in cases like these where you have to use the value of n after you extract digits from n, you store n into a temporary variable before the while loop and then set back n to temp. Okay, now when I compile, let me just change this back to 2. Now when I compile again and running again, I get the original output. Okay, one more thing is, if I make this 0 and I use the first approach. Okay, so clear, compile, run. Okay, 0 is not a Krishnamurthy number because 0 factorial is 1. If I make this 2, compile and run. I get 0 as a Krishnamurthy number because we are missing out on a border case here in this case. When n is 0, this condition is false. When n is 0, this condition is false. This loop will never run, so sum will remain to 0. 0 equal to 0 will return true, even though when we want sum equal to 1 for 0, because 0 factorial is 1. Okay, so you will have to add a separate condition if n is 0. Okay, sum equal to 1. All right, else, okay, you do this thing. Okay, because 0 factorial is 1, so right now it is correct. Or for more representational code, I'll say that it depicts what you are trying to do. You can do sum is factorial of 0, compiling and running again. Okay, so you see this string approach was straightforward and very simple, but in this approach you have to take care of the border cases happening, and that is why I often tell you to approach the same problem in multiple ways. Okay, because questions like these, very tricky questions like these, can come in your interviews, right? Like, what is the case missing and what will happen? Because one of the common mistakes is you do not save the value of n, then you use the value of n again, assuming it has not gone to 0. Okay, so things like this you have to take care. Okay, so this was the solution to this problem, and I hope this was helpful. You like this video. So if there is any doubt, this is a part you do not understand, please let me know in the comments. I always try to answer all your comments, and you can always let me know in the comments if there's a question you want to solve or if there's a concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.